All right, in this video, we'll be talking about the adjoint of a 3 by 3 matrix. This is quite different from that of a 2 by 2 matrix. And the procedure we'll be using in this video will be the cofactors transpose. So to get the adjoint of a matrix, of a 3 by 3 matrix specifically, you will have to find the cofactor matrix. And whatever you get as a cofactor matrix, you then go ahead to transpose that matrix. So we need to talk about how to find the cofactor matrix. So that will be the first thing we will have to deal with, solving for the cofactor matrix. And then after then, we will go on to be transposing that cofactor matrix. All right, let's take a look at this very beautiful matrix A. We're told to find the adjoint of matrix A. So the two major steps we will have to go through in order to find the adjoint of this matrix is step one, you will have to find the cofactor matrix C. Then you go on to transpose the cofactor matrix, and that will give you the adjoint of matrix A. All right, let's try and go through finding the cofactor of this matrix. How do you find the cofactor of a matrix, of a 3 by 3 matrix? Quite simple. The very first step you have to do is to go on to put a sign, to assign a sign randomly on every element of matrix A. How do you go about that? You start with a positive sign and you keep on iterating it. So you change from positive to negative to positive. Let's try and see how we do that. The first thing, this is the first element, you go on to put the plus sign. This is the next element, you put the minus sign. Then this is the next element, you put the plus sign. Then the next one after, you put the negative sign. Then the positive sign, then the negative sign, then the positive sign, the negative sign, the positive sign. That is the very first step you have to go through. Go on and assign these signs in this way on every element of matrix A. Then what you have to go on to do, because we want to find, let's put our cofactor matrix here. Our cofactor matrix is going to be of the same order. So you have a 3 by 3 matrix here. We'll be having a cofactor matrix that would be of order 3 also. So we would have the same number of elements that we had in matrix A. So we can call this first value the cofactor row 1, column 1. So that will be C11, C12, C13. Then C21, this is row 2. Then C22, this is row 2, column 1, row 2, column 2. Then C23, that's row 2, column 3. Then row 3, column 1, row 3, column 2, then row 3, column 3. So we will then go on to try and find each of the value of this cofactor matrix. And this is how you find those values. So you see this, the first one there, C11. So you have C11. How do you find the cofactor element C11? So you go on to look at the original matrix A. When you see the original matrix, you can notice that this C11 rests in row 1, column 1. You come here and you can see that the sign assigned to row 1, column 1 was a positive sign. So you go on to fix that positive sign. Then open a matrix determinant braces. So that's the first step. So let's go on to do for about 3 different cofactor elements so that you will be able to understand the procedure. So we can go on to write C12. This will be, of course, the sign for C12, looking at that, this is a negative sign. So you put the negative sign and open up a determinant braces also. Now you can see the next element that we have C13. C13. For C13, you can see the sign there is a positive sign. So you go on to have a positive sign and open up the determinant braces. So let's try and solve for these 3, then we'll go on to do for the rest. So how do you fix in the value for a matrix in this determinant braces? Of course, the same way we solved for the determinant of a 3 by 3 matrix. What you have to do here is understand that C11 rests in row 1, column 1. So C11 is in row 1, column 1. So you go on to cut off the entirety of row 1 and column 1. So you will shut off this whole value, this whole element, C11, and you will bring out the resultant matrix. So whatever is left is what you'll be filling inside here. So right here, we can see that we are left with, now you will not be the use of the sign that we attached on the top is only for this reason we have used it for here. So all you go on to pick is the element that was left. That will be -1, 3, 2, and -3. So that is how you go about this. So let's try and pick for C21 and see what we're going to get from there. So C21 is row 1, column 2. Row 1, column 2. So we are still interested in row 1. We are going to shut off the whole of row 1, and we're going to shut off the whole of column 2. So now we'll be left with 2, 3, 1, -3. And that's what we're going to be fixing inside our determinant braces. So 2, 3, 1, -3. So you can go on to do for C13. Of course, here we're interested in row 1 and column 3. So we are interested in still row 1, but we're no longer interested in column 2. So we are interested in column 3. So you go on to block off the entirety of column 3. And so we'll be left with 2 minus 1, 1, 2. And that's what you're going to fix as the element, as the value for the matrix in the determinant braces. So you put in 2 minus 1, 1, 2. Now looking at what you have right here, you can then go on to resolve this. So let's try and resolve these first 3 elements of the cofactor matrix. To find the determinant of this is plus sign here. You will have the plus sign. Determinant will be -1 times -3. That will be -1 times -3 will be 3. Then -2 times 3, 6. This obviously will give you plus times -3. And this will be -3. So the value for the cofactor C11 will be -3. And then let's go on to solve for C12. So we have the negative sign here. But we have 2 times -3. That will be -6 minus 1 times 3, 3. So that will be minus into -9. Minus times minus, that will be +9. Let's go on to solve for C13. What we have here is plus. Of course, this plus must be represented. Then you go on to have 2 times 2, that will be 4, minus 1 times -1, -1. That will be plus 4 plus 1, that will be 5. So our value here will be 5. So this way, we have been able to find the very first 3 elements of our cofactor matrix. So our cofactor matrix, we know C11 to be -3, C12 to be +9, and C13 to be 5. So we need to go on to find the other elements. All right, so we can go on to find C21, which will be, take a look at the position of C21, that's row 2, column 1. This is where row 2, column 1 lies in the original matrix, and the sign we assigned there was minus. So you put in the minus there, and you open the determinant braces. Then you can go on to write for C22. That will be where here we have the positive sign, plus then you open the braces. Then you can go on to write for C23. That will be the minus, and then you open up the braces. So to fill in these braces, there are values in these braces, these determinant braces. What you have to do is to go on to short off as we normally do. So we have row 2, column 1. This is row 2, this is column 1. So we'll go on to short off the entirety of row 2 and the entirety of column 1. So you can see what is left. We're left with 1, 1, 2, minus 3. So that's what we're going to fix here. 1, 1, 1, 1, 2, minus 3. We have to always be very careful when trying to bring out these values. This is most of the places where we used to have many students making mistakes. So then to short off for row 2, column 2, of course we have row 2 already short off, so we can just go on to short off column 2, as you can see. So right here, we have short off row 2, we are short of column 2. We are left with 1, 1, 1, minus 3. So that's exactly what we're going to fix here. 1, 1, 1, minus 3. Again, don't forget, I told you that the signs that we have is only for what we have used them for here. So don't go on to try to bring the signs in. Don't go on to bring in the signs. The signs that we attached on the top of them is only for this purpose. So we can go on to find for C23. That will be row 2, column 3. So this is row 2 and this is column 3. So we short off column 3. Row 2, we short off row 2, we short off column 3. So what we have left is 1, 1, 1, 2. So we can go on to evaluate the different values that we're going to get. And from here we can see we have the minus sign here. Then we find the determinant of the matrix we have within the determinant braces. So this is 1 times minus 3. That will be minus 3 minus 2 times 1, 2. This obviously will give you minus 3 times 2, that's minus 5. That will be plus 5. So we can go on to find for the next one, C22. That will be plus, don't forget the sign. Then we have 1 times minus 3, that will be minus 3, minus 1 times 1, 1. That will be plus minus 4. Plus times minus is minus, that will be minus 4. And then we have C23, the minus, then go on to find the determinant. 2 times 1, that will be 2, minus 1 times 1, 1. So this will be minus 1, because 2 minus 1 is 1. So we have a value of minus 1. So all right, now we've been able to get the values for our C21, C22, and C23. We can fix those values here. This is C21, we have 5. C22, we have minus 4. And then we have C23 as minus 1. Then we can go on to complete the cofactor matrix by getting the values for C31, C32, and C33. All right, so let's try and see how we can quickly resolve for C31. C31, which will be, this is C31's position. We have a positive sign attached there, plus then you open your determinant braces. Then C32, we have a negative sign. You open your determinant braces. Then C33, you do the same. And then let's try and fix in the matrices associated with these elements. So we have C31. Obviously, we'll be shorting off row 3 and column 1. So you can see we are left with 1, 1, minus 1, 3. You can pause this video at this point and try and solve this yourself so that you will be able to master the procedure. So the next thing to do is C3, 2. For C32, we'll be shorting off row 3 and column 2. You guessed right. So we're shorting off column 2. So you can see we'll be left with 1, 1. There's a 1 here. We're left with 1, 1, 1, 1, 2, 3. The key to getting the correct answer for the cofactor matrix is in getting this very right. So you have to do it very carefully so you don't go wrong. So the next one we want to do is the last but not the least. We have C33. Sorry, C33. So that will be row 3, column 3. So we're left with 1, 1, 2, minus 1. All right, so what we then go on to do is to resolve this. This will be plus 1 times 3, that will be 3, minus 1 times 1, that's minus 1. That will be minus 1. So this will be plus 3 plus 1. That will be 4. So our answer will be 4. And we go on, this is minus 1 times 3, that will be 3, minus 2 times 1, that will be 2. That will be minus 3 minus 2, that's 1. Then we have plus 1 times minus 1, minus 2 times 1, 2. This will be plus minus 3. Plus times minus is minus, you will have minus 3. So we can go on to fill in the values for our cofactor matrix. Now we've gotten C31 to be 4, and C32 to be minus 1, and C33 to be minus 3. So you can see right now we have been able to get our cofactor matrix, which is key to finding the adjoint of a 3 by 3 matrix. So the next thing to do to find the adjoint of your matrix is to transpose the cofactor matrix. The adjoint of A is equals to cofactor transpose. So this is the cofactor matrix right here, but this is not the adjoint. So if you write this down as your adjoint, that will be wrong. You have to transpose this. And how do you transpose that? Of course, you just have to interchange the rows with the column. So what you have right here, you have minus 3, 9, 5 as the row 1. It becomes the column 1. So just like this. Then row 2 is 5 minus 4 minus 1. That becomes column 2. And the last row there, which is 4 minus 1 minus 3, becomes column 3. So this way, we have been able to transpose our cofactor matrix, and we can obviously now call this the adjoint of matrix A. So this is the adjoint of matrix A given here. So this is how you find the adjoint of a 3 by 3 matrix. All right, let me see how you are able to resolve this. We have a 3 by 3 matrix given, as we can see, and we're told to find the adjoint of A. So let me get your results. You can just use the adjoint as, of course, this is the cofactor matrix. So just find a way to write it in the comment section what the element of each of the adjoint gives you in the comment section. I really love to see that. Thank you guys for joining. I hope to see you in the next video. All right, guys. Bye-bye.